Welcome to finding the length of curves involving polar coordinates, parametric equations, and function notation. So let's start with finding the length of curves of polar coordinates. Find the length of r of f of theta from alpha less than or equal to theta less than or equal to beta. So how to do that? Over here we have the equation. The length equals the integral of beta a, or beta to alpha, of the square root of r to the second plus the derivative of r, or dr over d theta, squared d theta. And that's going to be important because you need to know this equation when solving problems in real life or just example ones. So speaking of examples, over here we have one. Given that r equals sine of 2 theta, find the length of the curve from 2 pi to pi. So where do we start? We start by finding the derivative of r, or dr over d theta, and since the original was sine 2 theta, we use the chain rule to see that it would be 2 cosine 2 theta. And now we plug that into the equation that we used up here. So the length equals bound, or the integral, bounded by pi to pi over 2, the bigger one on top as beta, the smaller one on the bottom as theta, the square root of r, which would be sine 2 theta, squared, plus the derivative 2 cosine 2 theta squared, d theta. You plug it into your calculator, you'll see the length equals 2.422. And that's how you do polar coordinates. So parametric equations. Let's find the curve of the length of the curves. Find the length of x, f of t, and y, g of t, from alpha to t, alpha less than or equal to t, less than or equal to beta. So here's the equation on how to do it. Length equals the integral of b to a, beta to alpha, square root of the derivative of x, dx over dt squared, plus the derivative of y squared, dy over dt squared, dt. So let's find an example. Given that x equals 2 sine 2t and y equals 4 cosine t, find the length of the curve from pi to 2 pi. So what should we do? Start out by finding the derivatives. So the derivative of x, or x over dt, dx over dt, equals 2 cosine 2 theta, simply by using the chain rule. And to find the derivative of y, or dy over dt, we just use simple derivative functions, and you get negative 4 sine t. And now you plug that in, and remember that the larger value goes on top as beta, the smaller goes on bottom as alpha. So the length is bounded by 2 pi to pi, square root of 2 cosine 2t squared, or the derivative of x, plus the derivative of y, or negative 4 sine t squared dt. And if you plug that into the calculator, you get the length of the curve to equal 9.508. Now let's move on to the final one for function notation. So find the length of y equals f of x from alpha less than or equal to x less than or equal to beta. So how to do that? The length equals the integral of beta a, beta to alpha, square root of 1 plus dy over d theta squared dx. And that's obviously the derivative of y. So let's find an example. Given that y equals e to the x over the interval of 5 less than or equal to x less than or equal to 15, what is the length of the curve? So, like the other ones, we start out by finding that the derivative of dy, or dy over dx, equals, and since it's e to the x, it's the same, so it's e to the x. And the length of the curve is bounded by 15 over 5, since 15 is the larger one, beta, and 5 is the smaller one, alpha, square root of 1 plus e to the x, or the derivative of e to the x squared, equals dx. And you put that in the calculator, you find a very big number, and that's how you find the length of function notation. Thanks for watching.